Okay, thanks everyone for coming. Welcome to the second seminar of the SNR seminar series in the fall. Great speaker again today. I'm going to let Mike Hayes introduce her in a second. And all I'm going to say is that we've got another seminar next week. It's going to be 3 speakers actually. It'll be Eric Hunt, Deborah Bathke, and Ross Nixon, tag teaming the seminar from SNR. They'll be talking about climate change in Nebraska. And with that, I'll turn it over to Mike.
Thank you, John. For those of you who don't know me, I am Mike Hayes. I'm a climatologist here in the School of Natural Resources. So it's my pleasure today to introduce Dr. Barbara Boustead. Barb is a meteorologist, climatologist, and author of Wilder Weather, what Ingalls Wilder teaches us about weather, climate, and protecting what we cherish. Dr. Boustead has expertise in weather and climate communication, connections between climate and extreme weather, and weather and climate data analysis. She earned her bachelor's degree at Central Michigan University in meteorology, geography, and English, and has a master's degree from Pennsylvania State, and she got her PhD here in the School of Natural Resources. So she is a SNR alumni here. So Barb's going to give her presentation. We'll have some time for questions at the end. And then she also has her book if you're interested in and would like to purchase a copy up here after the seminar. So Barb's seminar today is Wilder Weather, Research, Communication, and Connection. Barb?
Thanks, Mike. Like any good author, I'm going to start with a little reading from the book that I have written, and then we can go into a little more. Ice is a solid, but it is not stable. It changes constantly. Even the thickest ice on a body of water in the middle of winter is not still. It can shift up or down, drift side to side, crack open, or freeze in an old crack. On most days, you can hear the ice sigh, groan, or whine. As ice slides, you can hear cracks, creaks, and pops. Nudged by the wind, the water currents, or sudden temperature changes, the ice moves audibly, like your arthritic relative standing up out of a chair with a groan and a popping knee. Walking on the ice is not for the faint of heart. Walking safely means knowing how thick the ice is and the character of the ice itself. Is it clear and smooth, the depths of the lake visible beneath its icy window? Is it milky with a bumpy surface as layers of snow have packed down and frozen? Is it slushy and soft in places? Is it cracked and shifting like tectonic plates as it breaks up, pushed by winds or currents? Despite its knee-trembling clarity, the clearest ice, sometimes known as black or blue ice, is the most solid and supportive. Milky white or gray ice can be stable too, so long as it is intact. But every trapped air bubble that gives the milky color is a potential weak spot. The snow on top can prevent the ice from hardening and adds weight to the load on the ice below. 2 inches of clear or black ice on a still lake is the bare minimum that will support the weight of a person walking on foot cautiously, but 4 inches is safer. 5 to 7 inches will support a snowmobile, an ATV, or a loaded wagon. 8 to 12 inches will support a car. As a rule, white ice should be at least twice as thick as black ice to support the same weight. It is also important to remember that no ice is guaranteed to be safe. In the days of covered wagon and horseback travel, crossing rivers was no small matter. Without bridges across the widest rivers, travelers relied on ferries for deeper rivers and fords for shallower ones. To spare the expense of taking a wagon across a river on a ferry and the risk of fording a river, early settlers could sacrifice comfort and cross while the ice still covered the rivers. The decision of when to cross became a balancing act of crossing early enough in the spring that the ice was still stable, but late enough that the cold weather would soon break. The Ingalls family crossed Lake Pepin out of Wisconsin in 1869 and again in 1874, both times likely in the late winter or early spring. Hi, folks, and thank you so much for taking time out of your afternoon to be here. I am very excited to join you all, and as Mike mentioned, I am an alumni of the School of Natural Resources. I studied under a couple of folks who are actually not here anymore, but I had a great experience while I was here. And the research that I'm presenting and what ultimately went into this book is had a strong foundation in the work I did while I was here as a student working on my dissertation. So for most groups, when I talk about weather, I just tell Laura's story. But for you all in this case, I'm going to tell a little bit more behind the curtains of where some of this research came from and how it stemmed from those seeds that were planted so long ago, it feels like, when I was doing my PhD work here. So a little more of a look at the process of putting this study together and what led up to it and what has happened since I graduated for this to become a book. So just a couple other things I'll say before I really get started. One question for you all. How many of you have read a Laura Ingalls Wilder book or had one read to you? Anybody watch the Little House on the Prairie TV series? Okay, and just one more. How many of you had ever heard of Laura Ingalls Wilder before seeing the title of this talk today? Just about everybody? That's good. And representative of something, and that is that Laura Ingalls Wilder is fairly deeply ingrained in the culture of America, especially in a certain region, the central US in particular, and recognizable. A lot of people were exposed to at least some parts of her books or the TV show or some parts of her story. And for some people, that might have just been a casual reading when you were in grade school, and that was the end of that. For others of us, we had those books on our shelves and read them over and over again, watched those TV shows for some people over and over again. What it turns out is that everybody likes to talk about the weather, right? You hear those casual conversations, and Laura Ingalls Wilder was no exception. Like so many other people, her safety, her life, her livelihood depended on it. And although she didn't put up instruments, Laura Ingalls Wilder was an observer. She didn't have to take readings. She described what was going on in the world around her, the impacts of the weather, the way it looked and smelled and felt. So she gives us another way to understand and analyze the weather she experienced, whether it be the big events or some of the day-to-day weather in her time. Let's just jump here. Because when it comes to understanding weather and weather records, we need those fundamental weather records, right? We need those observations that have been archived and kept. They've been quality controlled. They've been put into the archives at the National Centers for Environmental Information or in other places. They are a fundamental part of our understanding of past weather. They are not the only part. I like the analogy of digging up a dinosaur, right? You find these fossilized bones in the ground, and you can look at those bones, you can reassemble them, put them together, and you get a lot of information about that dinosaur. You can tell how big it was. You can tell what it ate, more or less. You can tell maybe how it moved, maybe what its younger offspring looked like, how big its eggs were, right? That's a good amount of information about that dinosaur. Classify it, name it, but it isn't everything. You can't tell what it sounded like. Can't tell what color it was or the texture of its skin. So what Laura's stories do, and other stories like hers, they put that body on the skeleton. They give us the sensory experience. They help us see the whole dinosaur, not just the shape of it. If we want a complete picture of historical weather, we need those observations. We also really need the stories. We need people to tell us what it felt like, how it impacted their lives, how it disrupted their lives, how it felt, how that cold air got into their houses, how the snow stacked up to the windows. All of those pieces of information complete the picture for us of these past weather events. And Our archived records are not the only records. There are also records from some other folks who happened to live here a lot longer than the European settlers, right? And we can get information about past events, weather and otherwise, from Native American counting calendars, or sometimes called winter counts, that also logged information about the past. All of these records come together to tell the story of what we know of the past. So I'm going to stop here just a little bit and go back into a bit of an origin story about this research in general, because if you're thinking in your head, how in the heck does somebody put Laura Ingalls Wilder together with weather? You're not the first one or the only one who's ever thought that. So the origin story here is that once upon a time, there was a little girl named Barb, and she was afraid of storms. She's about 3 or 4 years old. And does this thing actually work? Because it would be cool if it does. Oh, it's okay. I'll click. No worries. So little Barb went to the library with her mom and sister, who got tired of little Barb knocking on their door in the middle of the night when it thundered to say, "I'm scared of the thunder. Can I sleep in your room?" They took me to the library so that I could learn more about the weather, because knowledge and information empowers us to do things that make us feel safer. Little Barb read the books in the library and learned that the safest place to be during a thunderstorm is in the interior of a house. So I didn't need to knock on the doors of my parents and sister. I could just take my sleeping bag into the hallway and I would be much safer. And thus was born a little weather nerd named Barb, who went on to read all the books in the library about weather stuff and began a lifelong interest in the subject. But it wasn't my only interest. Sometime around first grade, around the time I told my mom that I wanted to be a meteorologist when I grew up, I was about ready to start chapter books. So she went to a garage sale and she picked out this book and gave it to me. And it had a cover with this covered wagon on the back, 2 little girls peeking out. And I kind of wrinkled my nose up at it. I didn't know if I was going to really like that book. And my mom said, "Just give it a chance. I think you're going to like it." Of course, moms are right so often, and she was right in this case. I loved the book. It was interesting. There was so much detail in it. Her descriptions were just powerful, and I felt like I was right there with Laura Ingalls Wilder running on the prairie. And I was hooked, read the rest of the books. Well, read them then, and continued to read them as a teenager, an adult even, until came the winter of 1880. I'm sorry, not 1880, that's the long winter. Just kidding, I'm not that old. The winter of 2008 to 2009. And yeah, it was a kind of cold winter, especially toward the end of winter. Like, the conditions just kept dragging on. It was cold March, there was a little bit of snow, and I was just over it. So I pulled a comfort book off the shelf to remind myself that every winter is going to end, even this one. Of course, that book was The Long Winter. And since I was a kid, I had read that book and thought to myself, there's so much weather in here, all these blizzards. Did that really happen? Or is she making these up? Did she exaggerate? For whatever reason, that particular reading, in late winter 2008 to 09, I reminded myself that I'm a meteorologist, and if I wanted to look it up, I could. So I did. And as often happens with scientific curiosity, my first question started just with, is there even data that can give me information? But the questions built from there because I found data. And it was a pretty serious winter. And then I started finding other accounts that also told of starvation and hunger and, cattle deaths and little tidbits of information here and there. The more I found, the more I backed up her story that it really was a fairly serious winter, and the more questions I had. Okay, it was apparently a severe winter, so the most severe or not? Have we had another winter that severe since then and we just don't realize it because we're not as vulnerable? Why was it that severe of a winter? Globally, like teleconnection pattern-wise, what was happening to make this severe winter happen? Was it small scale or large scale? So many questions. And I started digging into those bit by bit. By 2010, I had contacted the folks who run a Laura Ingalls Wilder academic conference. They were asking for proposals to present at their conference. The conference is called Laurapalooza. Wait for the Snickers. It's okay. It is an academic conference. There are very serious presenters there, also some very serious fans. All kinds of topics. But I went into that conference knowing that I was the only meteorologist on the agenda. Most other people there are, historians or literary professors, writers. Some are just flat out fans who've been researching things a long time, the kind of people who will go and look up census tracts to figure out who lived on what parcel of land during what years. Wide range of people. And I presented this little bit of work. And now I've had a weather service career. By that time, I had had a weather service career for, 10 years? Almost. And I've given a lot of presentations. And I had never given a presentation that was as well received as that one. And by well received, I don't mean that everybody applauded and that was that. I mean that I got so many questions. That's how a presenter knows when they've really hit something on the mark. It's when people give questions or come up later and ask questions. People kept coming up the rest of that conference. And as luck would have it, by the way, I was the only meteorologist. I was not the only scientist, though. There was a retired physics teacher who presented right after me, presented something kind of closely related to what I did. We didn't know each other before that, but it was one of those things where we both looked at something, came at the same answer from different angles, and like, whew, science. It was mind-blowing. It was exciting. People couldn't believe that these two people who had never met could get the same answer. But that's science, right? That's how we do it. People can approach a problem from two different methodologies and find an answer that collaborates. So he got a lot of questions too, and plus he was a really great, engaging speaker. We scienced the heck out of this Laurapalooza conference. But when I came back from that conference, I was just about to embark on the PhD program here. And I knew there was something interesting about that winter. Scientifically, I wanted to know more about why that winter was so severe and how to put it in context. But also communication. Why was this group of people who were not there for weather information so interested in the weather? I wanted to know how I reached them. What is it that made them hooked when I gave this presentation? Could I replicate it? So thanks to the grace of some really great advisors, I pursued this as my PhD work while I was here. And some tidbits of that are going to get sprinkled throughout. But that is the origin of how this all started. Now, in Laura's story, The Long Winter, I'm going to go through some pieces of The Long Winter in particular, because that's what I studied when I was here. She starts with quite a bit of reliance on folklore in her stories. And in particular, her father, Pa, notices muskrats building thick houses. We'll get to that. And he says, we know it's going to be a hard winter. The muskrat houses are so thick. Now, this being the School of Natural Resources, I can actually ask you all, is anybody studying muskrat houses in the relationship to winter outlooks or prediction? Probably not, right? Animal behaviors can be a predictor in the near term of some weather conditions. Like there are some animal responses to weather that are documented and feasible, right? Fish do certain things when the air pressure changes or when it rains, for example. We don't have anything on muskrats, and I think the groundhog teaches us all we need to know about the capability of mammals other than humans to make seasonal predictions. But that story clung, right? That's a sticky one. And people who read these books were thinking to themselves, well, how did the muskrats know? I don't know. Maybe Pa read something into their muskrat houses. It's hard to say, but I very much doubt the muskrats were out predicting the weather. There was also a story in Laura's book about an old Indian, an old Lakota man who comes to town to warn the citizens that it is going to be a hard winter. Every 7 winters is a hard winter. And every third 7 winters, that's 21 for people who need help with the math at this time of day, is an especially hard winter. And this was a third 7th winter, a 21st winter. So it was going to be an especially hard winter. Now, even as a kid, I had read some autobiography, or sorry, not autobiography, some biography of Laura Ingalls Wilder somewhere, and I knew the were of the long winter. Like, that was well documented for quite some time. Did I, as a child, go through and count up the years since 1880 to 1881, the years of the long winter, to see if I was going to get a hard winter that year? You bet. Did it work? No. As far as I know, there isn't a 7-year oscillation. Interestingly, as far as I know, there isn't even a folklore. I haven't been able to find one anyway. Maybe it exists out there and I haven't found it yet. But I've looked pretty hard and I can't find anyone else mentioning a folklore. So many winters in this part of the country is a hard winter. I do know that there's an ENSO cycle, and that oscillates on a rough period of every 3 to 7 years. Maybe somebody read something into that at some point and they whispered it around the communities. That is like a big stretch to make that assumption. But there's not even another corroborating tale of a Lakota man coming to town, let alone this 7th winter thing. And I still can't trace the source of that folklore. But it's hard to think that Laura made that up off the top of her head. She probably read it somewhere. I can't find it. If anybody ever finds it, I will buy you a drink of your choice. I might even buy you a cake. Let me know. So the winter kicks off with an October blizzard. And for those, is anybody from South Dakota, by the way? Just curious. All right. Now, I like to make fun of South Dakota as much as the next person who lives in Nebraska. They can have long and cold winters, but the winters don't typically start in October, especially east of the Missouri River. In this case, there was an October blizzard across the entire state. It started in the western part of the state. They do get October blizzards from time to time, but continued on over and lingered for 3 or 4 days. Now, Laura, in her book, this is the kickoff of the winter. She describes this October blizzard. In one of her draft manuscripts, she actually puts a date on it, October 14th, thank you very much, of 1880. And she's right. That evening of October 14th is when the rain turned to snow, the temperatures fell below 0, and things got a little rough in eastern South Dakota. So that's a pretty darn good memory, in my opinion, because it isn't like she could go online and look up the records from the past. She didn't keep a diary, so she didn't have it written down for herself anywhere. How she remembered that. And she didn't write these books until she was in her 60s. So this is decades ago, which says to me one of two things. Either she had retold that story so many times that it was alive and fresh in her memory, or it was so deeply imprinted on her as a trauma or a hard event can be that she will never forget it. One of those things must be true, because there's no record of her writing anybody to get dates or information about this. So the winter kicks off with this October blizzard. There's maybe a brief mild spell, but then winter really sets in by November. It's cold, it's snowing from time to time. The family who living on this homestead in a shanty, an uninsulated shanty with gaps in between the boards of the outer walls, decides maybe that's not enough of a shelter for the winter. And they move into town, into a store building, so that they have a more substantial shelter. And though she talks about a couple of individual blizzards, one in particular stands out. And it strikes when she and her sister are at school. In her story, they are at school when the blizzard strikes. By the time they have everything together and can leave, they can barely see, and they barely make it back to town. They only brush like the last building on the street before they would have been out in the open prairie. Had they not brushed against that building, they would have been lost on the prairie. It is another one of those tales that I don't have another account that says this is the way it happened, but it is very much like something that could be true. It also could be that because Laura lived in the same part of the country during the 1888 children's blizzard, that she heard stories about this happening to kids in that blizzard and wanted to add a bit of drama to her own story. Also could be true. Both could be true. Maybe she did get caught there, but it wasn't quite as bad as she made it sound, but she beefed up the story based on what she heard about the schoolhouse blizzard. Either way, the details she uses to describe what it was like to be caught in that blizzard are incredibly sharp. She talks about the feeling of her skin becoming raw because of the abrasiveness of the ice crystals of snow, which is something a lot of folks who haven't lived in this part of the country don't realize, that snow is not soft when it's being driven by a wind like that. It can rub your skin raw. And in her case, she describes that by the time she got home, she wiped her eyes and her eyelids were bleeding. She could see it on the back of her hand. So, and, you know, snow, she's wearing skirts, right? Because women wore skirts in those days. The snow caked up under her skirt and, you know, stuck in her shoe tops and everything else. Whether it was as dramatic as she describes and it barely made it back, or it was just super uncomfortable, right? These vivid details are memorable. And a bit of a lesson learned for people who don't have a lot of experience with weather in this area, that maybe being caught in a blizzard is not such a fun thing. By the time Laura gets later in the winter, and I'm skipping over some details because I don't want to talk about the long winter forever, around January in her stories, instead of describing individual blizzards, one at a time, the schoolhouse blizzard, the Christmas blizzard, the blizzard that strikes when they get back from an antelope hunt that failed. She just, is anybody a Seinfeld fan? Yada, yada, yada. She yada, yada, yadas a good part of the winter. Like, no details, just it kept blizzarding, right? It would blizzard for 2 days or 4. There'd be a day of a break or 2, and then it would blizzard again, and it was just snowing all the time and miserable. Which made me a little bit interested in that. You know, was it that her memory blurred there and she just couldn't remember the details? Again, she's writing these in her mid-60s. Was it that she was traumatized at that point, starving, cold? They were short on food, short on fuel, and she just didn't have the mental capacity to take up a lot of memory of what was happening then? Also possible. Was it just that snowy? I went back to the weather records. I was using a few continuous weather observing stations, so Omaha, Des Moines, Minneapolis, St. Paul. Those sites have continuous records that include the long winter of 1880 to 1881, but also continue until now. But that's not very close to De Smet, which is in eastern South Dakota, east central South Dakota. There weren't very many official observing sites, but what I did find were forts records. And these are weather records that were taken at the frontier forts or military forts around these parts of the United States that weren't so settled at the time. So there were several of those in eastern South Dakota, a couple more in Minnesota and so on. Those are a little closer to the site we're interested in. So that's a little more information I can use. Now, I don't get a long record from those. They were there for just maybe a few years or a couple of decades, and then they stopped. But it's still good insight into the weather at that time. When I looked at all of those sites and mapped them out, from mid-January through the end of February, that's 6 weeks, there were only 3 days that it was not snowing at least one site in the region, in that small region. So also, yes, it really was snowing a lot. It was a very active weather pattern in that time. Lots of days with snow, very little break, continuously cold, windy on a lot of days. So my suspicion about why Laura blurs her story there toward the end and just says there were just a lot of blizzards is all of those things. It was very snowy almost continuously, especially when you factor in the wind that lofts that snow on the days when it's not new snow falling, right? There's a lot of that sort of ground blizzard effect. She was traumatized. She was hungry. She was cold. Their house was barely above freezing, and it hadn't been for months. They barely had any food left. They were living on basically ground up wheat for months of that winter. And that's a long time to remember back in the past. I think all of those factor into why that part of the story becomes a blur, a blizzard of blizzards, if you will. Now, finally, by March, she starts to talk about a few breaks. It would get a break for maybe a few more days instead of just a day or two. The temperatures were a little bit milder. Weather records are going to support that too, turns out. They did get some breaks in the weather in March. They got a couple of days where the temperatures rose above freezing. Awesome. When you have a snowpack that is probably many feet deep and well beyond the records of anything we have observed since then, a mild day probably feels pretty good, melts things a little. And in fact, some of that runoff had already started to make its way into rivers and cause some ice jam flooding by end of March, even before the real thaw got there. And the real thaw did get there. When Laura hears something in the night, she hears the wind. Not just any wind, she hears dripping with the wind. The wind has changed. She jumps up. Pa, the Chinook is blowing. He says back, I know, Laura, go back to sleep. And in the morning, says to her, thanks a lot for waking us up to tell us the wind is blowing like it hasn't been blowing all winter. And she says, I said the Chinook. That makes the difference. So another pop quiz for everybody. Who knows what a Chinook wind is? Okay. This is one of my favorite parts because I get to teach something through Laura Ingalls Wilder's eyes. A Chinook wind is a downsloping wind. Comes up over the Rockies, okay? So it drops its moisture on the west side of the Rockies. And when it comes down the other side, the east side, the lee side, it is dry and it's compressing, so it's warming. So that warm wind and relatively dry then comes out onto the plains. And because it's warm, snow can melt. Because it's dry, there's a lot of room for those evaporated molecules of water to get into the air. And because it's windy, they then get shuffled away, so it can continue to evaporate on that snowpack. This wind is sometimes called a snow-eating wind, and it is a very efficient snow melter, a very efficient way to get rid of snow. I can look at the records and know exactly what day that Chinook hit. It was April 14th in most places, April 15th to 16th in a couple others. And I know it because high temperatures went back above freezing and never went below. Not only that, the low temperatures went above freezing, and except at the very northernmost site, never went back below. There is a multi-feet deep pack of snow on the ground. Do you know how hard it is to keep the temperatures above freezing at night above a snowpack? Very hard. If the winds are calm, if it's clear, it's going to cool to freezing or lower just by radiational cooling right at the surface. If it didn't do that, something was keeping it moving, right? The wind is blowing and or it's cloudy. There's a reason those temperatures didn't fall. And what happened that spring is that this record snowpack, some accounts, although there weren't any official snow depth measurements or snowfall measurements, some of the accounts that are in articles or journals say that as much as 11 to 14 feet of snow fell through the course of that winter. Safe to assume not all of it was on the ground by the time the spring thaw arrived, but safe to assume multiple feet of snow on the ground when that spring thaw arrived. So what happens in the plains when you take a deep snowpack and suddenly melt it? This is not a trick question. What? Yes, that is correct. You flood like crazy. And in that case, do I have a slide on that later? I don't. I was trying to be fast. There was record flooding in the spring of 1881, records that stood right up until about a decade ago in most places, because of that amount of water that had come out of the plains and melt through the tributaries and in through the waterways, down to the Missouri, down to the Mississippi, and shuffle its way out. Very wet in the spring, which means, so in that winter, the snow had stopped trains from bringing supplies into town. The snow had made it so that transport couldn't happen. That's why the residents were starving. That's why people couldn't get food and fuel. So the snow melts. Thank goodness, finally we can get the trains through. Not so fast, because the flooding waters started to take bridges out and undermine railroad beds. So they were still without trains for quite a while into the spring in some places because of that. I like to think about what it would be like to have a winter like that now. Although I don't know if it'll ever happen again. In our minds, we can imagine it would. So there are so many differences between then and now that have nothing to do with our ability to, say, plow the snow, although that's an important one. One of them is this. None of you really said you're from South Dakota, but Nebraska is not very different. It's not that common to have native growing trees. There are some that have been planted in shelter belts, but those happened mostly in the 1930s. So at the time, the landscape in South Dakota was very bare, not very many buildings to break the wind either. So the wind had very little impediment blowing across the prairie, which means it had the ability to blow faster, loft more snow, right? So easier to get those whiteout and ground blizzard conditions than it is now. In that era, railroads were the main source of transportation, especially of goods, right? How did we get things people needed into this part of the country? A little bit of barge in the summer, a lot of railroads. Without the railroads, they didn't have anything coming in. So if they didn't have it on hand, they didn't have it. A lot of people were close to starvation that winter. Not very many people were documented to have died by exposure. There are some accounts that suggest people did die of starvation or at least suffered from starvation. For us, maybe we can't get to the store for a couple of days. Might have to eat what's in our pantry. You know, I don't keep that much. Oh, I kind of keep that much there, but maybe not what I want that day. Our access to goods is much more reliable now than it was then. You might have to go without for a few days, but if you have more than, say, 4 or 5 days without being able to get to a store, unless you live way out in rural areas, you're going to be able to get that access, right? Lucky us. Fuel is another one. I mentioned that their fuel supplies were cut off because they were relying on fuel shipped in. A lot of folks in that part of the country had put in stoves that burn coal. Because remember what I said about trees in South Dakota? Not that many. You can burn cow patties, but that's not really optimal. That was definitely a last resort even in that era. And that implies that you have a cow that survived this winter also. What else are you going to burn there to make heat? They twisted hay into sticks when they ran out of fuel and tried to make it hard enough that it would burn a little bit slower. But it's still hay. It's not going to last very long. It's not going to burn very hot. They had to twist that hay almost constantly to keep a supply of it. Not a very good source of warmth. It was just enough to keep them from freezing to death, basically. Well, lucky us again, right? Most of us have pretty reliable heat. We have electricity coming into our houses, or we have perhaps natural gas fueling our heat in our homes. If the electricity goes out, yeah, that is a bummer, right? How many people have backup heat in their houses? I don't. I should probably, but I don't. So if the power was going to be out for long enough, I would have to go stay with a friend or something. So I guess we're all a little vulnerable, except that we're only going to be vulnerable for a few days. Once they ran out, they ran out. And then my favorite one, transportation, right? If they weren't going somewhere on railroads, not many people were traveling on horses either during that winter, right? Too risky. There were so many blizzards that folks just basically stayed home. When they happened to get a break of a couple of days in between blizzards, they went out, maybe went to the next town, maybe got the mail, something like that. Checked on neighbors, checked on friends. What do we do when it's going to snow? Well, yeah, what do we do during the storm when it's snowing? How good are we at staying home, keeping ourselves safe, staying off the roads, waiting for the threat to pass? Our society has gotten very bad at that, right? We have normalized a very dangerous behavior of putting ourselves intentionally out there at risk. For what? So that we can go to work, go to the store, go to class, teachers. Maybe in a virtual society, some of that pressure will come down, but there's still a lot of pressure for society to keep moving. Thus, pressure for cars to still be on the road. Cars are incredibly vulnerable during snow, during winter weather. They are probably the one thing I would say makes us most vulnerable to winter weather, more than those who lived during Laura's time, because they stayed home. They could, and they did. Now, let's start to get into more of the fun stuff. All of that stuff I did before, that was like part one of the dissertation, which was really just tracking down what happened, documenting the historical reports, along with the weather and climate records, putting those stories together. But I still wanted to know why. Because as scientists, we always want to know why. When I'm giving this talk to non-scientists, I make that point quite a bit, that we're like toddlers, right? We walk around, why? We argue, right? Scientists love to argue. Scientists love to prove themselves right, to prove someone else wrong, to say, my data doesn't say what yours says. There is something wrong here. We need to go back. When scientists agree, it's because the evidence is so compelling that there is not another possibility that will stand up to that scrutiny, right? It takes a while to arrive at that, especially for big topics or new topics. So when scientists come together, they'll probably still nitpick the details, but fundamentally on concepts, that consensus, that convergence of different methods coming to the same answer, like my physics teacher friend and I, tells us that the methods are leading us to an answer that is the most likely, at least until somebody else comes up with something that they have the evidence to put forward. So why did the long winter happen? In the world of global, what was going on? One obvious first piece is that it was a colder background climate, right? It was simply colder in the 1880s than it is now. So when you have that trend line, you take some deviation from it, some anomaly. It's this much colder than the baseline in that winter. In a colder climate, simply same deviation, but put it off of temperatures that are that much warmer. It's harder to get extreme cold when temperatures are warming. Not that it's impossible, it's harder. It's harder to sustain it for a while too. So that is one compelling piece that definitely we can't ignore. Another piece, I wish I'd have put these in a different order. I'm gonna switch that up. Because the next piece is actually the more compelling one. There are many global teleconnection patterns that shape the weather we're experiencing. No one global teleconnection pattern gives the whole story, but they can influence weather patterns. They can nudge things in a certain direction. El Nino and La Nina, one common global teleconnection pattern that nudges weather patterns. Another one is the North Atlantic Oscillation, or NAO. And when the North Atlantic Oscillation is in its negative phase, Areas along the Rockies and east have a strong tendency to be cold. And the stronger that NAO is in that negative phase, the stronger that relationship is. The opposite is true too. If it's a positive NAO, that area tends to be warmer than normal. In fact, it's a very strong relationship, stronger than the relationship with El Nino and La Nina in most places. Why don't we talk about it more then? I mean, sure, a lot of you have heard of El Nino and La Nina, is that right? Yeah? How many of you have heard of or looked into the North Atlantic Oscillation, or NAO? A couple of you. Ask anybody kind of out in the world. If you're looking, La Nina, that's gotten into the public discourse. NAO, not so much. But NAO has more of an effect. Why don't we talk about it more? Because we can't predict it. Not at the same time scales that we can an El Nino or La Nina. We can look ahead to an El Nino or La Nina at the seasonal timescales and have a pretty good idea if we're going into an El Nino, going into a La Nina, it's going to persist, or we're going to come out of it. NAO is maybe predictable at more like week 2 timescales, but predicting that it's going to persist in one phase or another, very tricky. Predicting its tendency through the course of a winter, not really possible yet by any means. We have found there are some people working on it. Maybe we'll get there. I would love that, but we're not there yet. The long winter, 1880 to 1881, was the strongest negative phase of NAO on the record since the mid-1800s. It was very negative NAO. Not really surprising, given that teleconnection pattern, that it was very cold that winter across most of the United States. All right, cool, we have one piece of the picture. The other one is the El Nino and La Nina. In this case, the winter of 1880 to 1881 was most likely a mild, maybe moderate El Nino. But El Ninos around the northern plains actually tend to be associated with temperatures maybe a little leaning warmer than normal. At least the tendency is there to lean warmer than normal. It's not a very strong relationship, but it's there. So that would suggest it would have offset some of that cold. El Ninos can also be associated with wetness in the southern plains, maybe nudging into Nebraska a bit. Whereas a La Nina winter tends to be sort of colder, maybe a little wetter up north, and drier and warmer down south. So how did we get this awful winter out of a combination that does have a very big contributing factor toward cold, but also a contributing factor that should nudge it toward warm? Multiple reasons, I think. And there's not a very big sample size, but where I could find winters that had a combination of a negative NAO phase and an El Nino, a lot of them were really cold and snowy. The winter of 2009 to 10 had that pattern. It was the closest match, actually, to the winter of 1880 to 1881 pattern-wise. Does anybody remember that winter, 2009 to 10? Some of the folks who were living here then. It was awful blizzardy in December. It was a Christmas blizzard. It was a blizzard earlier in December. There was another one a little later in the year. January was super cold. There was a snowpack that stuck around quite a long time into February. Then it got milder. The snow melted in February. March was pretty mild. That was the end of that. It was like the long winter without the long part. Almost like it's just harder to sustain temperatures that cold in our current base climate. But the patterns were similar, and the winter outcomes ended up pretty similar too. So I thought that was an interesting combination as well. And then, of course, in any time where we're talking about one season or one weather event, randomness and chaos is always part of the discussion. Sometimes things just align and happen for reasons either that can't be explained by a known teleconnection pattern or go against what we think they should be. Maybe there's other teleconnection patterns we haven't identified. Maybe there is something else going on. And there's just chaos in the system. You know, once it got that cold and snowy in the early part of the winter and that snowpack was laid down, it's awful hard to get warm again, especially in a colder climate. It's just hard to warm back up when there's a big snowpack on the ground. So that persistence can be a part of it too. But all of these factors combined to create this winter that was very severe. Well, how severe? This brings me to another part of the work that went into the dissertation. This part was fun. It was a collaboration with Mr. Steve Hilberg, who at the time, well, he is still retired from the Midwestern Regional Climate Center. We have the High Plains Regional Climate Center here. The Midwestern Regional Climate Center is its counterpart. At the time it was in Illinois, it's now at Purdue. Because we wanted to put a number to the severity of a winter. How do you quantify that? How do you take a winter and say, this one is more severe or less severe? So we came up with a scoring system that let us look at temperatures, snowfall, and snow depth. We assigned numbers, scores, based on the daily values of each of those. The higher the score, the more severe the conditions, colder temperatures, deeper snowpack, deeper new snowfall. And where we didn't have snow data, we used an approximation method to calculate it based on temperature and precipitation information that we had. So the outcome looks something like this. This is not the winter of the long winter. This is just an example because it illustrates it well. The red line is the of 1 year, 2018 to 2019. Black line was 2019 to 2020 at this location, which is Grand Forks. That rainbow of colors represents categories. Each of them percentile block, 20 percentile. So 0 to 20th percentile, 20 to 40, 40 to 60, 60 to 80, 80th and up. That 80th and up category is your extreme winters, right? The worst 20% of winters, the worst fifth of winters. Sorry, I have to correct myself. I'm not allowed to say worse when it comes to winters, and I still do it all these years later. Steve Hilberg loved winter. I wasn't allowed to say that winter is bad because winter is not bad to everybody. Some people's livelihoods depend on it. Some people just like it. Extreme, severe, not bad, not awful, Aussie awful. I was really tempted. Weather Channel calls this the winter misery index. We couldn't stop that train once it left the station. The most severe winters are those in that top 20th percent. The most mild winters are the ones in the bottom. You can still set record highs and lows. This is a spread based on the distribution of winters from 1950 to 51 to the most recent winter. So what you get is a score at the end of each winter that sort of characterizes its severity through that winter. Now, this is the winter of 1880 to 1881. Every site that's in purple recorded an extreme winter, that most extreme 20th percentile. The ones that were diamond-shaped were records, still are records. The record most extreme winter when we look at all of the historical data. And the area that's circled is where those records are, so that you can see it from maybe further back. Controversial whether I should connect those across South Dakota or not. I actually don't have an ob site there once I get north into South Dakota. That's a bit of an extrapolation. Could be there, could be not. Still extreme in that area, even if it wasn't record, but you can see where that winter was at its most extreme. DeSmet is in the green dot. I have no observations there, so I can say it was certainly extreme there. But was it the most extreme? There are other winters that also ranked very extreme up there. And at the closest sites, none of them were the most extreme. How in the world could something be more extreme than what that was? It turns out that there was another winter in that area that ranked more extreme, mostly because of the temperatures, not the snow. So this was the most extreme as far as snowfall goes. But when you look at the overall score, the winter of 1874 to 75 wins for the most extreme in that area, in most places. It was very, very cold that winter. By the way, Laura was living in that region that winter. She was living in Walnut Grove, which is basically south central-ish, southwest-ish Minnesota. so she experienced that winter. Why didn't she call that one the long winter? Why wasn't that the big one that made a whole book for her? I have theories. Oh, did you want to know them? I know where you can find it. Let's see, I'm getting close to time here. I have so many cool events to talk about. Maybe I just pick one or two. That's a cool one about a July 4th freeze that I traced down to occurring in July 1859 in the eastern US. Oh, okay, so this one, yeah, I'll tell this one because it's pretty cool. Has anybody ever seen that picture before, by the way? That picture makes the rounds. It's often cited as the first picture of a tornado on record. It's not, it's the second known picture of a tornado. And it occurred on August 28th, 1884, and was taken near Howard, South Dakota. So Howard, South Dakota, you can see on the map here, the tornado that passed near Howard. That star is De Smet, South Dakota. In Laura's book, These Happy Golden Years, she describes being on a buggy ride with her boyfriend, Almanzo. And they watch the clouds go from cumulus to billowing to cumulonimbus. She doesn't call them cumulonimbus, but we know what they are. Watches the storm start to rotate, watches lightning. Hello, get inside. Watches funnels develop, watches a tornado develop, right? She's seeing all of this happen at some distance. And the tornado, as you can see from the tracks, is going from northwest to southeast. They take a path toward the northeast to get out of the way of the tornado. Not gets them out of the way, or get them in the hail, but you know, not bad. Laura storm chases, maybe not on purpose, but she gets to see a tornado. The timing in her book suggests it was around the same time, and when you go look at her stories more deeply, would suggest that it was that day. And to further corroborate it, her story describes another one of the tornadoes near Forestburg, which is this one back here by the river in Sanborn County, that struck two boys who were on mules. The mules and the boys were thrown. One of the boys survived, comes home naked. The other boy died, and the mules died. And that exact account is included in Grzoulis's book, The Significant Tornadoes tome, that is roughly the size of a coffee table and contains information on all significant tornadoes since 1681 or something like that. That's Laura's tornado outbreak. That is the closest tornado to Laura that day. In all likelihood, Laura saw that tornado that day. And when I figured that out, I couldn't believe it. Like, that's a picture I've seen since I was a kid reading those books in the library. And there it was that I saw that tornado, and it is really cool. Oh, I know you drought people want to hear about drought. There was some. It affected their lives. The biggest drought that affected their lives is not the Dust Bowl, because they were mostly out of the area by then, but the South Dakota droughts of the late 1880s to early 1890s. That was a drought that drove a lot of the population of South Dakota to leave the state, and she was one of those two. Grasshopper weather. I know. I'm going to come to this point, which is the reason it worked to talk to people about Laura Ingalls Wilder and her weather is because it was a story. It wasn't boring weather facts. I found a character they trust, Laura Ingalls Wilder. I related to them because I talked about it with them, right? That's a story they can relate to. They've heard Laura Ingalls Wilder stories. They can see and hear how she talked about it, so they relate to that story. Those stories make them want to go to those places. They're transported by the stories, and it's congruent with their life experiences, their self-image, their expectations, right? This story matches something I want to be. I know I didn't get to everything, but thank you all for being here. The book is available if you want to come say hi. If you need time or need to think about it, you can also get it on your favorite websites. My favorite is my publisher, the South Dakota Historical Society Press, and they're also the fastest to deliver. Amazon seems to be on back order all the time. I have a Substack where I write sort of adjacent information to the book, where you get little tidbits here and there. So you can find my Substack as Wilder Weather, and I am happy to answer any questions. I have all night. I know you don't, but whatever you've got, I'll be here as long as you want me to be. So thank you all again. And I am really grateful for my experience at the School of Natural Resources planted the seeds that became this project that has carried so far into my future. I still love working on this project. I will work on it for the rest of my life. Thank you.
Thanks, Barb. I'm thinking the time, right? We might just have people come up afterwards for questions. Okay, so why don't we do that? So thanks again, Barb. It was great hearing all these stories. Let's thank Barb one more time. And yeah, come on up.